High temperatures affect coatings and composites very differently, and this boils down to the specific function of a coating versus a composite. Coatings provide a barrier between the atmosphere or surface and the substrate, whereas composites provide mechanical strength. They also provide barriers, but for this case, let's assume mechanical strength only to make this simple. So why does temperature play such a critical role with coatings and composites? Let's imagine for a moment that you have a 10-foot run of pipe. 5 feet of the pipe is in good condition and coated for corrosion prevention, and the other 5 feet is severely damaged and composite reinforced for strength. For this example, we'll assume the resin used for the composite is the same resin used in the coating, and this resin has a glass transition temperature of 300 degrees Fahrenheit. And glass transition is just a fancy way of saying the material is beginning to soften. So now, during operation, an upset condition occurs and the pipe reaches 315 degrees Fahrenheit for an extended period of time. For the coating, this temperature will cause it to soften. However, it won't simply fall off the pipe, and so it can still act as a barrier between the pipe and the atmosphere, which results in corrosion still being prevented. For the composite, however, this softening will weaken the resin, and in this case, the system may not be able to withstand the necessary mechanical forces, which leads to the result being zero mechanical strength added and a significant increase in the potential for failure. So, to simplify this, will temperature affect the resin's ability to do resin things? For the coating, it can still be a barrier, but for the composite, it may be significantly weaker.